Imagine you bought a house for 1.25 million. And when I say you bought a house, you purchased it, but not entirely using your own money. That's the case for most people, at least. You buy a house, but you borrow a large proportion of the money initially from the bank. So imagine you borrowed $1 million to pay for a $1.25 million house. So that implies, of course, that you have paid a deposit of $250,000. $250K you paid yourself. Banks will typically require you to pay some percentage up front to ensure that you're invested and that they're not taking all of the risk in case you can't pay them back. So 1.25 million was the cost. You've paid 250,000 and you went to the bank for the remaining 1 million. So the bank lent you 1 million, and this creates what's called a mortgage, where if you can't repay the $1 million to the bank, they then have the power to seize that property for the purpose of selling it. So I shouldn't say they take the property, they don't quite seize it, but they have the power to sell the property to the market to get their money back because you have defaulted on your loan. You have failed to pay back what you owed them. So when you actually sign up for this agreement, when you take out a mortgage, what a mortgage means is you're actually just taking out a loan from a bank, but it's a special type of loan because if you don't pay it back, they have what's called a security over the house itself. So the bank actually has the power to sell the house to get its money back in the event that you can't make your monthly or yearly repayments, whatever the agreement is, but typically it is a monthly repayment schedule. So imagine you borrowed $1 million from the bank. Now, what's the situation financially for you? Well, let's say for the next 25 years, you have to pay back the same amount of money each month. So that's a monthly repayment. It's the same amount every month. And this is how banks will work out the deal with you. And it's going to happen over 25 years, and you're going to be charged an interest rate. The bank doesn't lend you that money for free. They're actually going to make you pay more than $1 million back because you are actually taking money away from them. So they'll charge you 6% per year or per annum. That's what PA means, for as long as you owe the money. That percentage, of course, is applied to the amount outstanding that you still owe. So the 6% doesn't keep applying to $1 million. The 6% applies to whatever amount is left owing after every month. You might pay off a lot of money each month. You don't still get 6% charged to the 1 million because you don't owe them $1 million anymore. You've paid off some of it. And importantly, this interest rate, even though it's a yearly interest rate, 6%, it's compounded monthly, which means 6% per annum isn't actually the relevant number. The relevant number is the monthly interest rate. And the way you can figure out the monthly interest rate, because that's how often the bank is actually going to charge the interest, is to divide that by 12. So 6% per annum divided by 12, because there are 12 months in a year, will give you 0.5%. And if we want to express that as a decimal, that will equal 0.005. Sometimes it's easy to use the decimal in the formula that we're going to be using. In terms of the period now, it's 25 years that we've got this loan for that we have to pay it back. But actually, because we're paying back on a monthly basis, because the bank wants us to pay back the money every month, we actually don't care about the amount of years. We care about the amount of months. So 25 years multiplies by 12 to give us 300 months. 300 months is the relevant number, not so much 25 years. Okay, so you multiply the number of years by 12 and you divide the annual interest rate by 12. So you divide the rate, multiply the period. Okay, period is the length of time. Okay, so now we've got a compound in interest, and we actually need to pay back the same amount of money every month, which is why we would call this an annuity. Now, an annuity is typically where you receive the same amount of money every month or year, but this is the same idea here where you're paying back the bank every month. You're paying back the same amount every period, every month in this case, sometimes a year, to the bank. And because it's the same amount and it's regular, it is regular and recurring repayments, we call it an annuity. It's not like you're going to pay one amount of money over and then we're interested in what that becomes over time because of the interest rate. We're actually interested in what it becomes with all of these repayments being made 300 times. What's happening to the overall amount that we pay back to the bank? Because you've got all these different streams, all these different flows of payment. Think about it. You pay back the bank after 1 month, then the next month you give them more money back. It is going to affect every month the number to which interest is applied. Okay, so let's go through how to actually figure this out. We want to figure out what the monthly repayment must be such that after 300 months exactly, that is 25 years, we have made the repayments successfully. Okay, all money is paid back exactly after 25 years, which is 300 months. Okay, what monthly repayment, the same amount, is going to give us that result? I don't want to pay it back a month too soon, a month after. I want to know what amount of money, with all of the interest factored in, is going to allow me to be free of my debt to the bank exactly after 300 months. The last thing to note here is that AN, that's just a subscript N, it's just a symbol. A equals the amount owing after N months. And we're just going to use that notation throughout our working, okay? So let's begin working this out. So after 0 months, what I mean by that is the day you take the loan out from the bank, obviously you owe $1 million. Okay, no interest has applied because it hasn't even been a minute. I'm saying the second that you borrow that money, that's A0. No months have actually passed. After 1 month has passed, here's what's going to happen. And the order here is very important. Okay, so after 1 month, you have that $1 million that you have borrowed from the bank. You haven't paid any of it back yet. So what happens is you've held it. The bank has let you hold that money for a month. They will now charge you interest. That's a fee basically for holding the money. For as long as you hold money, they're going to charge extra. Okay, remember that's how a bank makes money. So $1 million times 1, because obviously the amount owing is still going to be $1 million times 1. That's just 1 plus 0.005. Now note, I'm getting the 0.005 from our monthly interest rate. You could also put there 0.5%. Just make sure that when you use it in a calculator, you include the percentage sign if you're doing it that way. Okay, so 1 plus the 0.5%. The 1 again is because obviously after 1 month, you still owe the full million. So $1 million times 1, plus you also owe 0.5% of the million. So that should make sense for that figure. Okay, what also happens at the end of the first month? Well, you make your first monthly repayment because you have to make them monthly. So we have our first monthly repayment. Now, the important thing is here that actually happens after the interest has already been applied. So keep that in mind. One other thing to note that is important here is that we should simplify this to $1 million. 1.005. It's just far easier to work with this. See how I've plussed 1 and 0.005 together? So we'll work with that, and now I will use the M again. So I've just rewritten that in slightly simplified terms, or slightly more simplified. So that's what we owe after 1 month. Now, I'm not going to do all 300 months here like this. I am going to do the first 3 months. I think that's the magic number here. Once you do 3 months, it gives you a lot of clarity over the pattern that is going to emerge, because that's ultimately what's going to happen here. There's going to be a pattern. We can then make a formula. We can generalize that pattern, and then we can find out what amount must be owing after any month that we want. So we just need to figure out, excuse me, we just need to figure out the pattern that is emerging. And once we know the pattern, we can find out the amount owing for any month. And obviously, if we want to know the end of the loan, we want to know 300 months. How much is owing after 300 months? If we want $0 to be owing after 300 months, we can substitute 0 in for the A300, and then we can solve the equation. That's where this is all going. Okay, so after 2 months, how much do we owe? Well, obviously, after 1 month, we were owing all of this. And just like with the initial amount, the first million, what happens is whatever you were owing the previous month gets multiplied by 0.5%. Okay, so we are going to have to multiply all of this by 0.5%. Okay, so pay attention here. That was the amount owing. I'm just going to put some brackets on the outside here, which is always useful. Always use brackets when in doubt. So 1 million, 1.005 minus the first monthly repayment, M, we are actually going to multiply that by 1.005. We're multiplying all of it by 1.005 because the 0.5% interest is applied to everything that was owing after the first month, because now we're in the second month. So you actually apply that to both of these parts here. So if we multiply 1.005 by a million bracket 1.005, right? This is how you expand brackets. If we multiply that, you can see, hopefully, that 1.005 times itself will create 1.005 squared. So we get 1 million 1.005 squared. And then what happens is we have to multiply that interest to the minus m, because that was also sitting there after the first month and into the second month. So minus m 1.005. So that's what happens after the interest is applied after the second month. But just like after the first month, once the interest is applied, you then subtract the monthly repayment. So this here is our second monthly repayment. Notice how the first monthly repayment has been absorbed into this amount and we get interest applied to it. Because now that M was already there for a whole month, it also gets the 1.005 multiplied by it. Okay, hopefully all making sense up to this point. I know it can get very kind of complex visually, especially when you look at all the working out, but it is important to follow the working out so that we can get to the final pattern that we want to see. Okay, last one here, A3. Well, just like after the end of the second month, how much is owing after 3 months? Well, the first thing that the bank will do is they will look at how much was owing after 2 months, how much has been sitting in there, and that amount clearly from the previous month is in there. We take into account the fact that you've already made another repayment. So the bank is not going to charge you interest on that. That's why it's minus M. Okay, so that's all factored in. But what the bank will do now is they'll say, okay, we'll take that amount that you owe us after the second month and into the third month, and we're going to apply 1.005 to it because that is the 0.5% plus what was already owing. So all 3 terms now get 1.005 multiplied by them. So you can see here that the first term, and I'll just make this clear here, it is the second A2, it is the second month, what was owing after the second month, that gets multiplied by 1.005 before, once again, another monthly repayment is made. Remember, all the monthly repayments are the same amount. That's why we just keep using M. They are the same number. Okay, so A2 times that, what's going to happen here? Well, we have 1 million times 1.005 to the 3. Hopefully you saw that because it already had 2, and now we're multiplying another 1.005. Doesn't matter that I haven't put brackets around it there. Okay, so minus, what about M 1.005? Well, that also already has a 1.005. So that is going to become 1.005 squared. Again, here I'm just multiplying this 1.005 by all 3 of these terms. Then I'll minus the other M. I should probably make this M black, right? So it's distinguished. This is a different one. It's the same number, but this is the one we're doing after the third month. And then finally, we will have, and I'll do it here, minus M. Remember the M that was sitting there after the second month, after that final repayment was made? That's going to get times by 1.005. But again, that doesn't mean we're adding more money that we owe. It's a minus, so it's actually taking away that. And what we then do is, of course, minus our monthly repayment. So just keep in mind that all of this is simply the 0.5% interest being charged to everything that was currently in the account, and then we minus the monthly repayment for the third month after. Okay, this is the most important thing. You need to re-watch that if it hasn't quite clicked, and you need to write it out with me as well. It's very important to write out the steps slowly. Make sure you understand each step, because if you do this 4 or 5 times, you will find it quite easy by the end. Okay, but you've got to go through that process of going through each step very slowly. Okay, now we're at this. Hopefully you can see a pattern emerging, okay? A pattern starting to emerge. I'm going to do a ... here. I'm not going to do all 300 months, but I'm going to say, generally speaking, what's happening? When we get to the end of a particular month, I'm noticing, and look here, I'm noticing that the $1 million is simply going to be multiplied by 1.005 to the power of whatever month it was. So see where it was A3? That's why there was a 3 there next to the 1.005 that was attached to the million. See after 2 months how the million has a 1.005 to the 2? So the 2 and the 2 and then the 3 and the 3, they always correspond to one another. So again, there is a pattern. So now I could find any month's amount owing by simply following that pattern. So what we're going to see here is 1.005 to the n. If I choose the 200th month, that's what the n represents, just any month, then I have to put 200 there, okay? What about with the m's? This is where it gets interesting. So what we can do is, first of all, we notice that the m's are all common here. So all the rest of the terms other than the million have the monthly repayment in it. It has the m. So we can actually factorize that m out to begin with, okay? We can factorize minus m. They all have minus m, to be clear. So what I'm doing is I'm factorizing minus m out, okay? And I'll try and make this clearer with this. I'm factorizing it out. And inside this bracket, I'm going to put in our terms. But look what was happening. What did the first m have? Just 1 next to it. I'm starting over here. Minus m times 1 would get us to that minus m, right? Minus m times 1.005 would get us to that one. See how they're just adding on? So the reason I'm doing plus is because a minus times a plus gives us the minus that we want. Okay, so if you put a minus there, you'll get it wrong because a minus and a minus is a plus, but the originals are not pluses, okay? So 1 plus 0.005 plus 1.005 to the squared. See, again, this is exactly what we have above, but the more months that we go into, the more of these that are just going to keep adding on. So what I do is a ... plus 1.005 to the... It's not to the n. You might have guessed n there, but notice how the biggest one in A3 was 2. Notice how the biggest power next to a 1.005 on the m for A2 was 1. Okay, so there's still an n amount of terms, but the power here would be n minus 1. And again, just look at the previous examples to see that pattern. See how for A3 the biggest power is 2? See how for A2 the biggest power is in invisible 1? That's what I mean by n minus 1 being the biggest one there. Okay, so we have taken the m out, we factorized the m out, and we're acknowledging that with each extra month, a new 1.005 will be added on with 1 higher power. Okay, so what's interesting about this is that the 1 plus 1.005 and so on is actually a GP. This is a GP, which is called a geometric progression, or rather it's short for geometric progression, okay? So a geometric progression is when the numbers are increasing or decreasing, right, by the same multiple. So it's going up every time. For me to get from 1 to 1.005, right? And remember, I just switched the order. I just switched those terms around in the previous one. That's why the 1 is first, even though you'd think 1 would come last. To get from 1 to 1.005, I have to multiply it by 1.005. But to get from 1.005 to 1.005 squared, I also have to multiply it by 1.005. So because it's the same multiple each time to get to the next term, it creates a geometric progression. And you should look at our videos on geometric progressions or other resources that we have on this to understand that. But basically, when you have a geometric progression, there's a neat formula that summarizes the sum of all of these terms. So when you have a lot of terms adding together that follow this particular pattern, you can actually just make a formula, or rather apply a formula, that will encapsulate all of these added together and will give us the final sum of them. So 1 plus all of this will be the same as, and this is the formula, I'll write it in red still, it is A, which represents the first term, right? And then it's going to be, in this case, R to the n, the rate to the n, right? The ratio, I should say. There's a ratio of 1.005 here. Over R minus 1. Okay? So what does all this mean? In this case, the A is the first term in the pattern. And that's why I switched the order before. So 1 is our first term. And the ratio, the R, is just basically the multiple. Okay, so it's called ratio, but the multiple, what number are we multiplying each one by to get to the next one? Well, we're multiplying by 1.005. Okay, and then the last thing you need to know is n, which is the number of terms, and in our case, weirdly enough, it's n equals n. Okay, even though that is n minus 1, if you added up the amount of terms, there is still the same amount of terms as the number that's down here, like the an there. So see how there was a3 up here? Have a look at how many terms next to a3 have an m in it. 1, 2, 3. So it's the exact same amount of terms, even though the highest power that you'll see is one less. Okay, so what do we do with this information? We apply it up here, okay, to get this general form. So I can find the amount owing after any particular month now by following the pattern. We know that the first one was 1 million times 1.005 to whatever the month is that we're looking at. And then we minus, and we get our M. And then, instead of writing the full pattern, instead of writing all of this out, I just instead write what the sum of a geometric progression is, and I insert those values, okay? So that's the benefit of this. That's what these financial questions typically entail. You don't have to keep writing out the long pattern. We can just do the A, which is 1, bracket R to the N, which is 1.005 to the N, because we don't know what N is yet, minus 1, all over 1.005 minus 1. Okay, so now we have that. That's our general formula. We have our general formula to find the amount that's owing after any month we want. We don't have to keep going through each one systematically like we did for the first three. So what we can do now is we're interested in what must this M be? Remember, we're trying to find M ultimately. What is the monthly repayment that must be made for us to have all of our debt paid off with the interest after 300 months? Well, we want to have all of the debt paid off. And remember, the A to the N, this amount here, A to the N, is the amount owing. I want that. I want A to 300. I want, after 300 months, the amount owing to be 0. So notice here what I'm going to do. I'm going to make that 0 equals. So the AN, A300 is 0. Therefore, 0 equals 1 million, 1.005 to the 300. Because again, this is A to the 300. I just want A300 to also be 0. Because the amount owing after 300 should be 0. We should have paid all of our debt off by this point. Okay, that's why I've subbed in 0 on the left side. That's why I'm not writing A300 anymore. Okay? So, we have that to the 300 minus M. We still don't know what M is. And I'll keep that red for you here. We don't know what this is. Mysterious M. And then we actually have... We don't need to rewrite the 1 outside of the brackets, but I'll do it anyway for now. Can be invisible. 005 to the power of 300. And then all of that minus 1. That's not included in the power though. Okay, so we have that. And then over 1.005 minus 1 is just 0.005. So what we get now is, this clearly goes over 2 lines, but this is all one line. Let me bring this down here. So 0 equals, and I'll just make a clear distinction here. Okay, 0 equals... right? We're going to put some of those numbers in our calculator. So 1 million times 1.005 to the power of 300. Put that in your calculator and we'll see what that comes out as. Let's put that in now. Okay, that is coming out as 4,466,969.81, so on, right? Keep the dot dots, store that number in your calculator. You don't actually want to round up or down. You don't want to do any rounding yet. You only do rounding at the very end in your final answer, because if you round too early, you can actually get the decimals in your final answer wrong. Okay, so always preserve the exact numbers all the way up until the end. So that's that bit. And then what we do is we have the minus M. And then next to it is this big bracket, right? Remember, there's this big bracket here. There's just a times between the M and the big bracket, of course. When there's a letter or a pronumeral like M followed by a bracket, there is an invisible times between them. So it's minus M times all of that. Once you put all of that in your calculator, that should come out as 692.99 ... Okay, so that's the number that's come out. So now it's starting to look a bit simpler. And what we'll do now is we want to get m by itself. The way you solve now is just an equation. You want to get m by itself. Well, because it's negative m and there's 0 on the other side, I'm just going to move all of this. I'm going to move this whole term here. This is just one term. I'm going to move this to the other side by plussing it to both sides, right? So I'm going to plus m times 692 to both sides, and that will cancel out on the right side, and it will move it over to the other side, right? So I'm going to move this over to where the 0 is. Okay, so they will be cancelled, and then what we'll see on the other side is m, or 692m, but I'll just do it with the brackets. M 692.99 ... equals the 44 number. I'm not going to do all of that again. ... That's that number there that is going on that side. And then the final step to get the monthly repayment is to divide off, of course, by the number that's still attached. Remember, this is what we're trying to find, the m just there. It's multiplying by 692, etc. So we divide by 692. That's how you get rid of it, using the rules of equations, ... And then because you do it to one side, you have to do it to the other side. That's the rules of equations. And what then happens is these cancel out, which leaves you with m here. We have m here, which equals that number, 4464969 divided by the 692 number. And what you're going to get there is, if we round it to 2 decimal places, we are going to get 6443.01. So $6,443.01 is what we have to pay every month to the bank to ensure that all of our debt is gone, including interest, after 300 months, okay? Importantly, you'll notice that if you multiply this number, 6443.01, by 300, because you have to actually make that repayment 300 times, if you multiply it, you're going to end up with a number that's almost 2 million. And the reason it's going to be almost 2 million, even though you only borrowed 1 million, is because of all of the interest that built up over time. So it really doesn't pay to take a huge loan like that out if you're trying to make a gain over time. But unfortunately, if you want the house 25 years before you can afford it, you're going to have to pay a lot of interest. But most people do think that's worth it. 6% of interest is a big interest rate as well. At the moment, interest rates are a lot lower than that, 2 to 3%. So be wary that interest over that many months is going to lead to almost double the amount of what you initially borrowed, okay? So hope you enjoyed that. I know that's a longer tutorial. It just does have a lot of steps. Hopefully, you can just skip to the steps that you weren't understanding quite as well. I'll do more practice questions with less explanation to make it easier. But look forward to seeing you all in the next video.